Okay, good morning. Now to start with today, even though you didn't have homework last night, I want to rectify a small mistake that I made in one of the questions that you had for homework, and it was B part 3. And you can see here, we had identified the common denominator as x by x minus 2 by x minus 4, and I multiplied each term by that, and then I cancelled, and all of that was fine. And then the next line, I wrote it down wrong. So instead of x by x minus 4 here, you'll notice at x and x minus 4, and I dropped the 2. I don't know why I did that, so that should have been 2x there. So this then would have multiplied out to be 2x squared minus 8x plus 3 by x squared minus 6x plus 8 equal to 5x squared minus 10x, and this would have been 2x squared plus 3x squared minus 8x minus 18x plus 24 minus 5x squared plus 10x equal to 0. So that is 5x squared minus 5x squared. They all actually cancel, and I'm left with 8 minus 18 is minus 24 plus 10 minus 14x and plus 24 equal to 0. So minus 14x is equal to minus 24. X is minus 24 over minus 14, and x is, divide those both by 2, by minus 2, 12 over 7. So just one value for x there because the x squared's cancelled. So apologies for that mistake. Excuse me. And yeah, I'm just double checking the figures there. That's correct. Yeah, that's correct. Okay, moving on then. Back to our discriminants, our two distinct real roots, our two equal roots, and our complex roots. And I just want to do an extra example before we do the harder ones that are in the notes. So a couple of extra examples here. This up here. Extra examples. Just one extra example, actually. For each of the following quadratic functions, so for each of the following, determine whether the function has real, equal, or imaginary roots. So which of the three types do we have here? And the first one is f of x equal to x squared plus 9x plus 3. And the second one is g of x equal to x squared plus 5x plus 25. And the third one will be h of x. These are just function names, which we're used to from junior cert. We just haven't seen them in a while, maybe. So h of x is x squared plus 5x minus 1. Okay, so we're going to determine the nature of the roots. Now we could go ahead and solve these, but we don't need to. So we don't need to solve these. At least we don't need to solve these fully. All that matters is the bit under the square root sign, in the minus b formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Basically, if this is negative, we're going to have imaginary roots. If this is positive, we're going to have real distinct roots. And if this is equal to 0, we're going to have equal roots. And that has a special name, and it's called the discriminant. So it's called the discriminant because it helps us to discriminate between the different types of roots. So the discriminant is b squared minus 4ac, and it has three possibilities. Either it is equal to 0, and if it's equal to 0, I'm just going to call it d. So if my discriminant d is equal to 0, we have real but equal roots, two values that will be the same. If my discriminant d is greater than 0, stand of it, my discriminant d is not equal to 0 but strictly greater than it, we have real but distinct roots. Distinct meaning different. And the third possibility is that it's negative. If it's less than 0, then we have imaginary, or what are sometimes called complex roots. So in order to answer this question here, we have to work out the discriminant for each of these. So let's use my A, B, C, A, B, C, A, B, C. So for part 1, my discriminant is going to be the square root of b squared minus 4ac. So that's going to be the square root of b squared 9 squared minus 4 by 1 by 3. And that gives me the square root of 81 minus 12. Oh, I didn't pick a good one there actually. That's okay though. So the square root of 81 minus 12, and I get the square root of 69. And that's a number, do you know what guys, I'm sorry. When I do the discriminant, I don't do the square root sign at all. I don't know what I was thinking. All I care about is the b squared minus 4ac without the square root sign at all. So that should be 9 squared minus 4 by 1 by 3, which is 81 minus 12, which is 69. 69 is greater than 0. It's a positive number. 69 is greater than 0. So therefore, we have real distinct roots. The second one, my discriminant will be b squared minus 4ac again. So that's 5 squared minus 4 by 1 by 25. And that's 25 minus 100, which is minus 75. So this time it's negative. This is less than 0, so therefore we have imaginary roots. And the third one, we've got my discriminant b squared minus 4ac. So 5 squared minus 4 by 1 by a minus 1, which is 25 plus 4 greater than 0. So again, real distinct roots. Now your homework tonight will involve doing some of that work, calculating the discriminant and then deciding on the nature of the roots. So we didn't have one where they were equal here, but it will come up in our notes. So we'll leave that one there. Now let's move back to the notes, and we're back on page 31. So this page with this diagram at the top, and you can see the notes mention the discriminant. Okay, so same as what I wrote in that extra example, distinct and real, my discriminant is greater than 0. Real but equal, the discriminant is equal to 0. And imaginary or complex, the discriminant is negative, less than 0. Okay, here's how we often get asked about this. We're given a quadratic equation here, and we're told that it has equal roots. So if it has 2 equal roots, if you ever see this, this is like our keyword, that means that b squared minus 4ac is equal to 0. So the first thing we do is we write down b squared minus 4ac, which is going to be 6 squared minus 4 by 1 by k in this case. And we know that that is equal to 0. We know that that's going to be equal to 0. So we have 36 minus 4k is equal to 0, minus 4k is equal to minus 36, and k is equal to 9. So when k is equal to 9, this has equal roots, 2 equal roots. And you could check that. You could put in the 9 there, and then when you solve this by factorizing or by the minus b formula, you'll get x plus 3 by x plus 3 as our factors. So x is equal to minus 3 is the one value there. They didn't ask us to find the roots. They only asked us to find k, so we don't need to go any further. Now, if we look at a question like this, for what values of k does this have equal roots? So again, equal roots is the big one that we tend to get asked about. B squared minus 4ac equal to 0. A, B, C. It's a little bit less clear in an equation like this, but the coefficient of x is 1 minus k. So A is 2, B is 1 minus k, and C is 2. Filling into b squared minus 4ac equal to 0, I've got 1 minus k squared minus 4 by 2 equal to 0. So I square out my brackets and I solve for k. And you'll notice the question said values. So we know that we'll get more than one answer. More than one answer. So here, square the first, we get 1. Square the last, k squared, and double the product, minus 2k, minus 4 by 2 minus 16 equal to 0. So I've got k squared minus 2k minus 15 equal to 0. And we can factorize this. K minus 5, k plus 3 equal to 0. So k is equal to a plus 5, or k is equal to a minus 3. Okay, so that's how we use this. This is worth noting as well. If the discriminant is greater than 0, but it's a perfect square, like 16 or 25 or something like that, then the roots, the answers will be rational. So they will be no square root in the roots. Okay, so I'll put your homework up in Google Classroom to practice with those, and let me know if you have any questions. Thank you.